David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Today's topic, exponential function review. We're going to go over everything we did in this chapter and give you a bird's eye view of all the stuff. As always, if any of these topics still gives you some trouble or some struggle, then you want to drill back into the individual video for that part and make sure you master it. Okay, generally, exponential functions are functions that have variables in the exponent. So, x squared is not an exponential function, but 2 to the x is an exponential function. So you've got to see a variable in the exponent for it to be an exponential function. Okay, if you graph exponential functions for growth, they tend to just keep on going up. Okay, so as time goes by, usually the x-axis is time, the y-axis would be something like population or money or something like that. Most of the exponential functions that we dealt with went through this particular point, 0, 1. They always intersect the y-axis at this point. And that's because of the form of the equation. Okay, general equation forms that we explored are f of x equals some constant k times a, which is the growth rate, to the n power, which is usually time. So this is usually time. This is the growth factor. And this is the starting amount. So let's do an example of one of these types of problems. Let's say we have some kind of experiment. We have a petri dish, and we've got 500 cells in there. Okay, these cells grow over time. We've given them enough food and water and everything they need to be happy and grow. So here we're giving you a population. Population as a function of time is 500 times 2 raised to the t power, where t is in hours. So now we can calculate how many cells we're going to have at any point in time in the future. In fact, let's do that. Here's our question. How many after 6 hours? If you feel comfortable, pause the video, see if you can get that calculation. Okay, let's set her up. So the way I'm going to write this is p of 6, because 6 is the time that we're going to use for this one, equals 500 times 2 to the 6th power. Okay? Now, you have to be able to raise numbers to powers other than just squaring them on your calculator. So make sure you can do that. If you do the math on this, you're going to get 32,000 cells. Okay, along the way, we did some compound interest calculation problems. These are pretty straightforward. You do need to have this formula to pull these off. So let's explain it. Future value is derived or calculated by taking the present value, multiplying it by 1 plus the interest rate raised to the power of the number of years. So this equation can be used to answer a question like this. Invest $6,000 at 5.25%. How much do you have after 15 years? So we're going to do the plug-in step first. And I urge you to resist doing math during the plug-in. Just plug your values in. So, how much is left? That's our future value. That's what we don't know yet. But it's going to be the present value, 6,000 times 1 plus the interest rate. Now, 5.25% is a percent. It's not a regular calculating type number. You've got to convert it into the correct decimal. And that's going to be 0.0525. So 1 plus 0.0525 raised to the 15th power. So that's the number of years, that's the n. Here's my 1, here's my rate, converted to a proper decimal, and here's my present value. So I'm going to take this one more step here, and then we'll get out the calculator. Future value is 6,000 times 1.0525 raised to the 15. Now at this point, it's okay to get out your calculator, do all the calculating, and come up with your answer. And what I got was 12,926.56. Answers to money questions have dollar signs and cents. Okay, so make sure you do that. Also, you should probably notice that I put $6,000 in the bank, got 5.25% interest. 15 years later, I have more than twice what I started. Not bad for no work. Okay, then we moved on and did some exponential equations solving. And as I said in that particular video, you need to be up on your rules of exponents. Now, I've provided links to those, to some exponent review videos that are taught in another class. So you might need to drill back on the weekly planner and go find those links and watch those videos, if that stuff is still hard for you to remember. Okay, so we'll do a basic one, then we'll do a little bit more complicated one. The way we do this is we equate the bases. So we make the bases the same, and then we can solve with ease. So 2 to the x equals 32. Well, I can't do much more with that base. That's just 2. I can't express that as a power of something else, blah, blah, blah. That's stuck. But 32 I can work with. So I can carry down my 2 to the x. 32 is 2 to the 5th power. So 2 times 2 times 2, all the way 5 times, is going to be 32. So I can write 2 to the 5th. So now 2 to the x equals 2 to the 5th. Equating bases, we've done that. We have 2 2's. So they can just drop away, and I get x equals 5. So now that's a fairly simple one. Let's do a more difficult one and see how that works out. Okay, so 4 to the 3x equals 64 to the 2x plus 1. Now, what we do here is we look at our bases and we try to figure out how to equate them. Now, it's true that I can write 4 as 2 squared, and I can write 64 also as a power of 2. But I'm going to leave this side alone because 64 is also a power of 4. So if I can rewrite this side as a power of 4, then I can equate it with this side and we can solve. So I'm just going to go to the right here. 64 is 4 to the 3rd. And I keep my 2x plus 1. Okay? So all I did is I changed 64 to a power of 4, which is 4 to the 3rd. Now I can use the power of powers law for the exponents. This one is just going to be 4, and then I multiply this power by that power, which is going to be 6x plus 3. So 64 to the 2x plus 1 is the same as 4 to the 6x plus 3. So now let's carry this down. I bring down my 4 to the 3x, my 4 to the 6x plus 3. Now I have equated bases, so they can go away. I have 3x equals 6x plus 3. Now I need to rearrange my equation so I can solve it. I'm going to subtract 3x from both sides, and I'm going to subtract 3 to move it over there. So I'm going to get minus 3. I'm subtracting 3. And then subtracting 3x, I get 3x is left. So if I divide through by 3, I'm going to get x equals negative 1. And that's the solution to that one. Okay, now we moved on to logarithms. And logarithms are the inverse operation to raising to powers. With our logs in this chapter, all we did is base 10 logs. Okay, so log 1000 is asking the following question. What power of 10 makes 1000? So the answer to this is 3, because 10 to the 3rd equals 1000. That's why log of 1000 is 3. Now think about this one. This is a little bit more tricky. What power of 10 makes 1 over 100? The answer is negative 2, because 10 to the negative 2 is 1 over 10 to the 2, which is 1 over 100. So that's where that one comes from. Okay? Now, a lot of the log questions you're going to get are going to have the following instruction. Don't use your calculator. So with a lot of these, you might use your calculator to verify something, but be able to do these in your head. Okay? Now this one is a little bit more tricky. Log of 153. You can't do that one in your head. Not, maybe some people can, but I sure can. But I know one thing. I know it has to be bigger than 2, because log of 100 is 2, And it has to be less than 3 because log of 1,000 is 3. And 153 is between 100 and 1,000. So it's between 2 and 3, 2 point something something, but I'm going to put it in my calculator, and I got 2.18. So this is 2.18, okay? And that's because 10 to the 2.18 is going to approximately equal 153, okay? Okay, I want to ask these questions backwards because this will help you when you're doing the logarithmic equations work. Okay, so how would you write 1 as a log? Think about that for a minute. How about this? Log 10. What log 10 is asking is what power of 10 makes 10. So 10 to the 1 makes 10. So 1 can be written as log 10. Now this is a little bit more tricky. Write -1 as a log. This would be log of 1/10. And this is because 10 to the -1 equals 1/10. Okay. So -1 can be written as log of 1/10. Okay, let's do some logarithm laws. So these are the 3 laws that we developed in class. They're pretty simple. If I have a log of a product, I just take the individual logs and add them. If I have log of a quotient, I just take the individual logs and divide, find the difference. And finally, if I have a log of a power, the power comes out and it's times just the base, the log of the base. Okay, so let's do some problems. I'm just going to do 3 straightforward ones for you. Log of 10 minus log of 2. Now I'm noticing that I'm subtracting, so I'm going to use this law and I'm going to run it backwards. So this is going to be the log of 10 over 2, which is the same as log 5. Okay? Now this one, I'm adding. But I have a problem here. I can't use the law, I can't use this one, the products law, with a number out in front. So I can rewrite this as 2, or as log of 2 squared plus the log of 3. The log of 2 squared is the log of 4, so I have log of 4 plus the log of 3. Running this law backwards, it's just times, so this is going to be the log of 12. So that's what I would get for this one. Last one, let's take a look at this. 9 can be written as 3 squared. So this becomes log of 3 squared. I'm just going to carry this one over, log of 3. I think you see where I'm going. My logs are now the same. So if I use the power rule to rearrange this one to log 3 over log 3, the log 3's cancel out and I just have a 2. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.